this is question 5 from the set of exam questions, and this one involves working with cardinal directions, which is quite a common sort of twist that might make you think a little bit. My advice, as always, with most mechanics questions is to draw an effective diagram. So let's start by getting the first parts out of the way. So we start at 7 a.m. and at 7:36 a.m. we're at this place. So we find the difference between those two, 4i plus 6j minus 2i plus 9j. That gives you 6i minus 3j. Yeah. And this is in 36 minutes, which is 3/5 of an hour. 36 over 60 equals 3/5. And so we'll do 6i minus 3j over 3/5. And that's going to give us 10i minus 5j. Done. Position vector t hours after leaving the port. So this is another one of these situations which you're probably familiar with now, having done a few of the questions, where they are just asking you for this new vector, which you could call r. And that's equal to r0. That's our initial position plus vt. So r0 is minus 2i plus 9j. And then v, we already know, is 10i minus 5j times by t. So as always, when you do this, you are wanting to rearrange to get all your i's in the same place. So here I will have 10t minus 2i plus 9 minus 5tj. Really straightforward so far, nothing atypical whatsoever. But here is the kind of twist. At 8:48 a.m., a passenger on the ship notices that a lighthouse is due east of the ship. And then at 9 a.m., it's now northeast of the ship. These terms, east and northeast, are really important because they mean that we're dealing with two angles, either 90 degrees or 45 degrees. And that means that we are parallel to the I and j vectors for 90 degrees. And when it's 45 degrees, we form isosceles triangles. So what does our effective diagram look like? Well, we have a passenger on the ship. So this is where the ship is first. We could call that A. And then we notice that the lighthouse is due east. So we could call that L for lighthouse. The lighthouse obviously doesn't move. But later on, we are due, well, southwest. The ship is due southwest of the lighthouse, or the lighthouse is due northeast of the ship. And I'm using my squares here, but I'm making sure that I actually try and draw it on so that it is northeast. The closer your diagram looks to real life, the more effective it will be. And in this case, it is really important because it allows us to see, to spot a couple of things that will help us with the question. So we know then that, first of all, we are due east. Well, actually, we need to work out the position vectors of each one first, right? So at 8:48, this is 108 minutes, or 1 hour and 48 minutes, or 1 hour and 4/5. So if I take my position vector and I let t equal 1 and 4/5, or 9/5, then I get my position is that's 18 minus, why did I put I here? Let's get rid of that. So I'm just subbing it into my position vector for the ship that I have. So 18 minus 2i plus 9 minus 9j, which is equal to 16i, and the j's cancel out there. So I know that this position here is 16i. Here's where east, as in the word east, is important, because we are perpendicular to the j vector. We're parallel to that I vector, and that means that we can figure something out about this here. Because we're on this straight line here, because we're due east, we know that these j components must be the same for the position vector. So that means that the j component is 0, basically, right? Now that gives us one half of the thing. We're assuming that we might get the other half from somewhere else, but that's a good start. We know that we have 0j. At 9 a.m., the time is 2, so that gives me 20 minus 2i and 9 minus 10j, which is 18i minus, minus j. So this position here is 18i minus j. I'm actually going to write this over this side so it doesn't get in the way. But that doesn't directly help us get anything necessarily. What we do know is the relationship between B and L is that L is northeast of B. So if I think about how these two things are related here, I know that this is a 45-degree angle, right? It's northeast, it has to be. And what that means is if I think about these positions in a triangle like this, or just the distance from here to here, that distance from there to there must be the same distance as there to there. These two sides of my triangle must be equal to each other. Why? Well, because this is a right angle triangle, and that means that is 45 degrees, which makes it an isosceles triangle. Well, because we know that this is 0j here, we know that that distance down there is just j. So it's like a distance of 1, which means that this distance is also 1, which means that if we're 18i here, we must be 19i there. So this is how you are using the cardinal directions here to your advantage. You know that that's a 45-degree angle. You know that proportionally, therefore, the horizontal distance to the point must equal the vertical distance to the point. So this is just something to remember if you're ever in this situation again, where you have one thing that's northeast or southwest or south whatever, if you have that situation again, it's worth remembering that the horizontal and vertical distances must be equal to each other because of that triangle that you're producing. So I've got my position vector then is 19i plus 0j, or of course just 19i. Now, find the position vector of the ship when it is due south of the lighthouse. Now, I saw some interesting diagrams for attempts at this question. Let me just copy what I did here. This is A, this is B. Right. When it is due south of the lighthouse is going to be some point here, right? It's going to be along that line. Now, this ship is only moving in one line. Its velocity is constant. It's not accelerating in any direction. It's just saying the same velocity. So that means its position vector will progress in a linear way, right? It's not going to curve off to the side here or down here. It will continue going down. So that means we'll end up here, south of L. We know that this is 19i, of course, and from this diagram, or just from thinking about the situation, you should be able to see what we do know. What we know that about C is the I component of the position vector must be 19. It's in line, it's due south of L, and so it must have the same I component, much in a similar way to how we knew that this had a J component of 0 because it was due east. When we're due south, we have the same I component. Well, what that means is we know what the position vector is of our ship at any given time. It is this 10t minus 2i plus 9 minus 5tj. So 10t minus 2i plus 9 minus 5tj. Okay, well, in that case, we already know what I is. We know that it's 19, so we'll set 10t minus 2 equals 19. That gives me t equals 2.1. And so here I'll just set t equals 2.1. And that gives me 9 minus 10.5, which equals negative 1.5. So my position vector, which is what I'm looking for, is 19i minus 1.5j. Done. So this question is a good example of how you're using the cardinal directions. There's just a couple of key things to remember.